Hi, we have prepared this video to provide a very high level overview of what is data science, what is the purpose of data science, what are the problems that can be solved using data science, and why organizations require to are in need of data scientists to solve some of the problems related to data. And what are the tools and technologies which are required for any person to become data scientist? And why do we need to learn these technologies or tools? And what is the purpose of having this? And is it really required that we need to learn all these tools and technologies? And that's what we are going to understand in this video. As you could see, I have mentioned a lot of things like data science, statistics, machine learning, deep learning, NLP techniques, and also some of the programming languages like Python or Spark, etc., etc. Is it really required that we need to learn all these things? I will say yes. To sustain in the current competitive world, especially the rapidly growing data science world, it is definitely required that people should be knowing all these tools and technologies. So before going and jumping into understanding what is data science and what is this tools is all about, what is machine learning, etc., etc., first of all, let's try to understand what is the data is all about. What is the life cycle of a data? As you could see on the screen, data will have a life cycle. We all know that any data will get generated at a transactional level. You take an example of a bank. So bankers will start entering the data from their machines. If you wanted to withdraw some money, or if you wanted to deposit some money, you will go to your bank where the banker will enter the data related to your transactions. And the days has changed where people started using mobile banking, or we have started using a lot of apps to do that, where all these machines are mobiles or either ATM machines. All these things will start generating huge amounts of data, where people will start archiving this data, which is called as data warehousing, because organizations cannot continue to store the data in the transactional databases, which will cost a lot for organizations. So having some of the data or latest data on transactional system is something which is good for any organization. But if they wanted to maintain the very older data, for maybe for example, why do organizations require to store the transactional data which is 10 years old, which might be required but which is not required every time? So to save some of the cost, organizations will move that historical data into data warehouses, so that that historical data can be used to analyze the business flow or some analysis related to business. So that's when actually the life cycle of the data will start, or the warehouse of the data starts. And now if you look at, it's not that people will wait for 10 years or to store the data, where once the transactional systems are completed or process the data, organizations will start storing the data into data warehouses to make sure that they will be able to extract the data as quickly as possible, and they will be able to analyze the data as quickly as possible. So that's when all this process of descriptive analytics will start, right? Where business people are required to understand what happened. They need to understand what happened today. What is the sales today? And what was the sales yesterday? So compared to last month, what is the sales? Is it increased or is it decreased? And I can understand that something is happening. Why it is happening? That's where people has to do some diagnostic analytics, which we also call it as why did it happen. And like people like all the ETL people, business intelligence, business analysts, and all those people are going to work on all this descriptive analytics and diagnostic analytics, on understanding what happened and why did it happen. So if you look at all these people, like until starting from a developer, a front-end developer or back-end developer, or either a business analyst or an ETL developer, or either a person who works on visualization tools. All these people are going to help you to build all these systems or to maintain the data up to this level. But if you look at all these people will have access to all this data which is getting generated in these systems. So if needed, they will be able to understand, they will be able to do anything or able to solve any problems using this data which can be solved by any of these people. They will have access to all this data. But what if business wanted to understand what is going to happen next month, or what is going to happen in next quarter, how much demand I'm going to get? I need to understand, the business people required to understand what is going to happen in the future so that they can procure the things that they need. Take an example of manufacturing industry. To manufacture a four-wheeler, it costs a lot. They need to procure lot of independent components from a lot of different organizations or different vendors. Without they knowing what is going to happen in the next month or how much demand I'm going to get for the next month or next quarter, it will be very difficult for organizations to do their planning or manage their resources effectively. It's all about future data. The biggest problem for any finance sector is understanding the fraudulent people or identifying the fraudulent transactions or identifying the fraud claims. If organizations can identify a fraudulent person or either a defaulter right before approving a loan, that's going to help organizations to save a lot of efforts and save a lot of money. Can we say that by looking at a person, can we say that this person is likely to become a defaulter? No, which has to be decided by future. So whether this person is likely to become a defaulter or not is going to be decided by future. But we need to understand that future data. So that's when, so you need to understand all these critical patterns. You need to identify all these critical patterns within the data. And that's not possible with any of these people who we are talking about, business intelligence or business analyst and all these people. And that's when the need of predictive analytics has come into picture. What is predictive analytics? So we are going to make use of machine learning algorithms. We are going to build models using machine learning algorithms that can use the historical data to build a model out of it. That model is going to provide us the future data. I want to predict a person is likely to become a defaulter or not. So once I build my machine learning using all my historical data, that model can take the input of a new applicant or new person who is trying to apply for a loan. That model can give us the output saying what is the likelihood of a person to become a defaulter or not. And if I can feed all my historical data, 10 years or 5 years of historical data to my algorithm of my sales data, that algorithm can produce a model out of the historical data, and that model can provide us how much sales we are going to get for the next month or for the next quarter. And that is where the data scientists are required. We are the people who are going to work on the problems which cannot be solved by the other people like ETL developers or business intelligence people or business analysts. And we are the people who will be able to solve those problems and generate the data for future or predict the data for the future. And if you look at this image, a data scientist is someone who is not only limited to build predictive analytics. Based on the problem that we are going to solve, we are definitely required to go to any level to understand the data or to identify the data. If the data is not available in your current existing data warehouse, for example, but you are in need of the data, some data that requires you to build some analytics on top of it. In those cases, you should be capable enough to influence any data warehousing people, or either influence any of the programmer to start extracting the data that you need. If requires, you may have to start writing that code. That's where you can see a data scientist is the one who will cuts across all through all these systems, who should be having fair understanding on all these aspects. If requires, the data scientist should also extend their data for any other outside network or outside environment like social networks. I wanted to build a sentiment analysis. Let's say, for example, you are working for one of the organization who will distribute movies across globe, and that organization requires to know whether a movie, people are positive about a movie, people are giving positive reviews about a movie or negative reviews about a movie. So being a data scientist, I'm going to depend on some of the social network data, maybe like Twitter or maybe like Facebook. I'm going to extract the data and I will build a sentiment analysis on top of it to understand whether people are responding positively about that movie or negatively about that movie. That can give me confidence that yes, I can produce this movie, or I can purchase that movie to distribute in my country. It's not that all the bigger organizations are only required to build analytics. It used to be luxury long before, but it is becoming mandatory that each and every organization should start depending on the data and understand the data and to take right decisions at the right time. So what is that skills? What are the skills that we need to become a data scientist? What are the skills that we need? It's all about processing or extracting the data. Your data might present in any of the data warehouse system. Your data might present in any of the social network. You might have to depend on any other kind of external data, or either structured data or unstructured data as well. So to process the data or to do all these activities, you are definitely good at computers or IT background. So you should have some fair understanding on some of the programming languages. You should be capable of doing all these activities. So when you are going to deal with the data, it's all about numbers. It's all about analyzing your data in numbers. What was the sales? What is the demand? Whether a person is likely to become a defaulter or not. It's all about dealing with your data. So statistics or mathematics is the best or simplest way to understand or analyze the data. This statistical knowledge will provide us very additional capabilities to analyze or understand the data very easily. And very importantly, domain or business knowledge is required for a data scientist. So in this course, we can learn, in not only this course, you take any course for data scientist, anybody can teach computers or IT background, or anybody can teach mathematics or statistical knowledge which is required, but none can teach the domain knowledge. None can teach the domain knowledge. Nobody can teach domain knowledge apart from you gaining the knowledge on your domain. So as we were discussing, to produce the future data, we are definitely required to build some machine learning algorithms. We are going to use machine learning to build the models out of it. We need to use those algorithms. So what are these algorithms? The origin for all these kind of algorithms is artificial intelligence. So artificial intelligence is a super boss or supreme for everything. So artificial intelligence can solve any of these kind of problems like related to data. And if you look at artificial intelligence is divided into machine learning, natural language processing, etc., etc., based on the type of data that we have. So let's say we wanted to deal with some structured data where we wanted to build some algorithms on top of, or build some models using some algorithms on top of structured data. That's where we'll be using machine learning. So machine learning is something that we can use it on top of some structured data to build some solutions out of it. And when the data goes to the unstructured level, that's where the text data is also next level of any data. Like whatever the data that we'll get in social networks, especially on, if you take WhatsApp messages, or if you take any of the Twitter messages, or either any of the blogs. So NLP techniques to process the data, we need to understand the algorithms which are present in NLP techniques, which is one more level. And if you go into one more level of unstructured data, we'll be able to see voice, we'll be able to see what is image processing, we'll be able to see video processing, etc., etc., right? So all the problems, these artificial intelligence, so machine learning is a subset of artificial intelligence, NLP is a subset of artificial intelligence. So artificial intelligence also has a lot of other things to deal with, like robotics, planning and visions, like computer vision and speech recognition and image processing, etc., etc. So data scientist, being a data scientist, since we are going to mostly deal with the structured and some of the unstructured data related to text format data, most of the data scientists are required to understand machine learning and NLP techniques. It is very rare situation that people will work on building some robotics where people are expected to learn artificial intelligence. They will be working on such an algorithms called building robotics, etc., etc. So what is this machine learning? What is it different? Is it something like we are going to learn something which is very new? Is it something that we are simply going to do a lot of mathematical expressions, do some very complex coding and all? No. It is a slight difference from what we are actually, or what any other simple programmers are doing. So what is machine learning? If you look at a human being, we all know a lot of things. We all learn a lot of things from our ancestors. We learned a lot of things from our parents. We learned a lot of things from our colleagues. We learned a lot of things from our friends. How do we know that how to communicate with others? How do we know that how to dress properly? How do we know that how to drive a vehicle? It's all about experiences. It's all about the experiences that we have already gone through, and we are trying to apply it in a very effective manner for the daily routine. So that's where the difference lies between a smart bot versus a machine. A machine will blindly follow the instructions. For every instruction, for every different input that you want a machine to perform, you need to give a different instruction. But the next generation machines or the smart bots are not required to give or take instructions for everything. You need to give capability to a machine that itself can take the decisions on its own. You're not required to give instructions. You should give the capability to a machine itself to take decisions. And that's what the difference between normal machine versus a smart bot or a machine learning enabled machine. What is the data science workflow? Or what are the things that, being a data scientist, what are the things that we're going to work on our daily routine? So just to start with anything, a data scientist is the one who should be able to understand the business problem first of all. What is the problem that I need to solve? Being a data scientist, what is that I need to solve? I wanted to build a model that can predict the sales, or that can predict the demand for future. I wanted to build a model that can predict whether a person is likely to become a defaulter or not. Or I wanted to build model using a machine learning algorithm that can predict a person is likely to become a defaulter or not, or either a person is likely to become a diabetic patient or not. This is what is the first step. So we need to understand what is the problem that we wanted to solve for our business. Do I need to build a model that can predict the future demand, or do I need to build a model to predict whether a person is likely to become a defaulter or not, or either a person is likely to become a diabetic patient or not, or is this data is something that I can consider to take a business decision? So what is the decision? So what kind of problem that you need to solve? That's what the very first step of a data scientist to start with. After understanding that, you need to see what is the data. Do I have enough amount of data to solve this problem? Where the data is present? And if I don't have that enough data, I need to start exploring more options to see how can I start extracting the data from other systems. What kind of data that I can depend on to solve this problem? So if you look at business understanding or data understanding, you need to have a pure domain knowledge to complete these two steps. So this is where you are definitely required to understand the domain of any organization or domain of your organization. And none can teach the domain knowledge without you going and working on any domain. None of the training institute will give you that or can teach this knowledge. Any course. And the next step is going to be data importing, because once you understand that, okay, I have my data available in a social network, I have my enough amount of data available in my data warehouse, I have my data available in this so and so files. Start importing the data wherever you wanted to build your model, maybe be it your laptop or be it your server, the server that you are going to work, or be it the cloud environment that you are going to work at. Start importing the data at one place, or be it a data warehousing also. You might start importing the data into a data warehouse. Okay, try to make sure that you are accumulating all your data at one place. Considering that the data is going to be having a lot of issues, either you start extracting the data from a highly matured data warehouse system, or either you try to extract the data which is cleaner data sets. Whatever it is, consider that being a data scientist, always the data is going to be as dirty as possible. It's going to have a number of issues. You need to make sure that you are solving all the problems related to data, to make sure that your data set is clean. Once your data set is available, you should start building your statistical modeling, apply machine learning algorithms and build your statistical modeling. Once your data is ready out of the statistical model, once you are able to produce the data for future or whatever the data that you are trying to generate out of these algorithms, you need to provide that data to your business as a visualization, because none of the business people will understand the numbers as is. They're not going to look at the reports that we are going to generate. They will only look at the visualization. So visualization is the best way of representing the data and easiest way of representing the data, especially for the business people. So if requires being a data scientist, we should be capable enough to build a report or build a visualization out of your data that you're going to produce. Considering these n number of steps, there are n number of tools which are available. Because you cannot say like the data will be available only in a particular database. Your data, your n number of organizations will use n number of different sources of data. It can be available in a SQL server, it can be available in Cassandra, it can be available in MongoDB, it can be available in any other big data technologies. There are n number of ways that organizations will store the data. Whatever the source it is, we should be capable enough to extract the data and apply some transformations out of it. So to extract the data, to apply some transformations on top of data, we have a lot of tools available. Either use any of the warehousing systems, either use any of the programming languages, either use any of the simple tools which are available like Alteryx, or name or anything. You can use any tool. There are no restrictions for anyone to say that you need to use only this particular tool, apart from some commercial softwares or some commercial applications. So to build the statistical models, to generate statistical models using machine learning algorithms, you can also use any. It is not that we have restrictions for any programming language. We can use any programming language. So the machine learning concepts will remain same. The machine learning algorithms will remain same, either be it a logistic regression, be it a linear regression or decision trees. You can use anything to apply your models, but there are some programming languages, there are some softwares or tools which are available where these algorithms are already implemented. Like if you say R is a statistical programming language which is purely created for a data scientist to work. So n number of algorithms are already available in a form of packages or libraries where you just have to use those algorithms which are existing. So you just have to feed your input data. Once your input data is ready, you just have to feed that input data to those functions or the models, and which is going to generate an output for us. So considering that, Python has scikit-learn as a library which has a lot of machine learning algorithms contributed for the open source community. Big data technologies, in the big data technologies, Spark has some of the algorithms which are already contributed for open source technology. So you can use any based on your need, based on like either if your data is available in a big data where you have huge amounts of data, and you may have to use something called Spark. And if your data is available so that in a small size and you wanted to build your model or train your algorithm in your machine where you can make use of Python or software, you can do it. Considering these are open source technologies, you are allowed to use any of these technologies. You either use R, either use Python, either use Spark or whatever it is. There are some commercial softwares like SAS, SPSS Modeler, which are also supporting some of the machine learning algorithms, which comes with a cost. But they are also implemented with the same algorithms, same machine learning algorithms. You are also able to get the same machine learning algorithms implemented in these open source technologies as well. But the way that you are implementing, the tool that you are using is different. But at the end, you are going to use the same algorithm, which is going to produce same output. And visualization, you can use any visualization, either considering that R or Python also provide some of the libraries to build the visualizations. Like R has something called ggplot, Python has something called matplot library or some other libraries. You can use any of these things. So if the organizations might have different tools, for example, you take me for example, there was one of the organization which I'm working with, they want me to use Alteryx to do the data transformation because they have procured license. They want me to work on or use Alteryx to extract the data, to do some transformations to make sure that the data set is clean. And they said like, okay, you can use whatever the programming language that you are comfortable with. Earlier I used to work on R. That's why I used R to build a statistical model. And they have a visualization tool called ClickView, and we used to build visualizations on ClickView. So what are the other tools? Is it something like you're always going to extract the data, connecting it to a database, and then extracting the data and applying transformation and building the model? No. You might have to extract your data in a different format or a different way. Maybe you talk about structured data or you talk about streaming data. You might have to explore for more and more number of options. What is the best way to extract this data in order to solve this problem? So the data can be of anything. We should not restrict ourselves to any kind of data or any kind of database or any kind of software or any kind of programming language. At the end, we are only going to extract the data, do some transformation to make sure that your data is clean, and build the model using machine learning algorithms and build the visualizations. So on a high level, what are the things that we need as we understand? You need to have a complete clarity on what is the problem that you need to solve or you are going to solve. To solve that problem, to understand or to work with all these things, you need to have understanding on machine learning. You need to have some basics about statistical or mathematical knowledge. You need to understand how to process your text formatted data. You need to know how these algorithms works. You need to understand what is this algorithm is used for, why it is linear regression, why it is used, what is decision tree, why it is used, or when to use what. What is a priori algorithm, when to use this algorithm, what this algorithm is capable of doing. What is sentiment analysis, what is TF-IDF, what is term frequency and inverse document frequency, and how to implement them is what we need to know, or use anything. So if you look at what are we going to learn, or what are the things that we are going to learn as part of this course, we're going to start understanding or exploring the options to see how to understand the data, or how to explore the data using statistical methods, like what is frequency distribution, how the data can be measured using dispersions, what is skewness, what is kurtosis, how to deal with the data, what is hypothesis testing. First of all, why do we need to do hypothesis testing, what are we going to produce out of hypothesis testing, and how to build machine learning algorithms. This is what we should be knowing, because if you look at all the other programming languages or any other people, a lot of people will be having understanding on a computer science background. Most of the people, they'll be able to write queries to understand some of the data, but these are the things that we should be learning apart from what other people, or like ETL people or business intelligence people, are going to learn. So is it something that we need to really understand about, we need to really know or learn big data? Yes. You can also say yes, not big data is not at all required. Yes, I will agree for that. But considering that we are entering into the world of digitalization, which is making the amount of data to grow enormously. If you look at the amount of data which is getting generated by these social networks, or the way that the data amount of data which is getting increased in any of the warehouses for any of the organization, people are finding it very difficult to store them. So earlier it used to be like people used to store the required data only. So whatever the data which is required, the organizations used to store that level of data only, where the remaining set of data, or the other set, other kind of data which they used to just simply purge it. They used to purge the data. A data is lost once, is lost forever. You can never rebuild the data. So that's when organizations realized that it is very important to store the historical data, because they don't know in what situation, at what kind of situations they are going to in need of, they are required to refer that historical data. So that's why now the things have changed because of the arrival of Hadoop technologies or the big data technologies. Everything has changed. Whatever the data it is, organizations are just simply storing everything into these Hadoop technologies, which are completely open source technology, and they can store and process the data for highly cheaper cost. And that's where the industry is looking forward to migrate, the data industry is looking forward to migrate into the world of big data technologies like Hadoop, Spark, or any other NoSQL databases. Our organizations still, they were believing, or they were still in the normal systems like bid, depending on some small chunks of data, but a lot of organizations are now already started getting into the world of big data to meet the future needs, or to cope up with the future needs. So if you are definitely wanted to meet the current industry standards or the future industry standards, you should be definitely knowing these big data technologies. And that's what is different. Is it something like we need to learn R? Is it something like we need to learn Python? Is it something like do I need to learn some other technologies like SAS or anything? It's up to you. But I will say Python and R, considering that both are open source technologies, none of the organizations will give restriction, because anybody can just simply download it, anybody can just use it. There are no restrictions. Only thing that organizations will look at you is produce the data. What kind of quality data, or what kind of quality algorithm that you are able to produce, and what is the accuracy, how good you are able to solve the problems. So if you say, for example, if you take me for example, there was one of the problem statement that I was trying to work with where I don't have that library available in Python, and that library is available in R. So I've used our package in that organization to solve one kind of problem or to solve one business problem. And considering that some of the alignments are not possible, some of the data flow is very difficult to, or data extraction is very difficult to do using R, and some organizations are preferring Python to use. Anything is open source technology, there are no restrictions. Considering that R is a highly powerful programming language which is purely and only created for statistical purposes, R has too many number of algorithms implemented, too many number of packages or libraries implemented only for data science. But even if you look at Python, Python has too many libraries even than R, but Python is not only for data science. Python is almost for everything. Using Python, you can do a number of things. But if you look at scikit-learn, the libraries or the libraries which are available only for data science, R will have more number of data science packages. Python will have packages apart from data science as well. So Python is becoming very or growing very fast because of it has packages, it has extensions created for other technologies, other not only just for data science everywhere. So like you can build front end, you can build backends, or you can build Selenium testing, you can build a data engineering, you can do a number of things using Python. But R is restricted only to build statistical or only to be used for data scientists. So considering that big data is something which people can use, Spark is a processing engine which is growing rapidly, where most of the people are finding it very easy to implement their big data technologies or process big data using Spark. So Spark has, I would say, the first and best open source technology which is available, who is actually providing to build the algorithms on big data technologies, because we cannot use Python or R to work on big data, because Python and R work only on a single machine. So in big data technologies, the data will be distributed across multiple machines. The way that the big data processing, the big data has to be processed, everything is completely different. You cannot use the libraries which are available in Python and R. So if you wanted to build something on top of big data technologies, definitely as per the current or future industry standards, Spark is the best one. Spark is most preferred by most of the people. So what's new in this? We are going to considering these industry standards or considering the future needs of industry. I have added Python, R and Spark in this course, where it is just I made this course as a one-step course where you're going to learn everything that you need for a data scientist. We're going to learn machine learning. We're going to learn statistics. We're going to learn or understand about big data. We're going to learn how to use Python programming. We're going to learn how to write R programming. We're going to learn how to write or use Spark to process your data on big data. We're also going to learn NLP techniques as well. And also deep learning as well, how to implement deep learning algorithms. What is deep learning? What is neural network? How to implement a neural network? Everything we're going to learn. As you could see, the course content that I have, we're going to understand, first of all, this is just a very high level overview. We're going to understand in details about what is data science, what is machine learning, what is the actual difference between normal programming versus machine learning. And we're going to start with program learning. Okay, let's start with, because I know that most of the people who are trying to get into the world of data science are coming from non-IT background, or mostly from background where people don't have knowledge on programming. So we're going to start with a very basic level. Basics of Python, R, what is big data, what is Hadoop, what is the architecture of big data, how actually these big data technologies work, and how this data will get processed on distributed systems. And we will understand those basics first. And then we will start with how do we apply a statistics, or how do we do the basic mathematics using this Python, R and Spark. And then we will actually getting into the actual data science, understanding machine learning algorithms. It's not that I'm just going to show you how to implement a machine learning algorithm using Python R. The very important thing is you should understand how a machine learning algorithm will work. What is going to happen in machine learning? Let's take an example of linear regression. So to implement a linear regression using Python, either using R or either Spark, you just have to use a single command where you will be able to implement your linear regression algorithm. Not only linear regression, any algorithm is just a single command because it is already available. Someone has already implemented for us. It is just available as a single function. Single command can build linear regression algorithm. But we need to understand, being a data scientist, we should understand what is happening. What happens when you're execute that algorithm, how the algorithm will read, what are the internal things that will happen. What is linear regression uses something called least squares error method. What is this least squares error method? How this data will happen, will get processed, how the linear regression will build a model out of it, what happens internally, what is the mathematical calculations that will happen. And that is what we are going to understand this. I just don't show, or I didn't show the examples only to implement these algorithms. We are going to understand about deeper insights of every algorithm. And not only just that. So based on my experience, it is not that you just have to build the algorithm. Let's say, for example, there are few of the things, a lot of people will do a lot of mistakes. They don't know how to implement the end-to-end related algorithms. Let's say, for example, linear regression again. We have something called verifying linear regression assumptions. A lot of people doesn't verify those assumptions. It is very important that when you are working in real time, it is very, very important that you should verify the linear regression assumptions after building your model to make sure that the algorithm will really work when you deploy the code into production. And if you take logistic regression, for example, understanding logistic regression is simple, but you need to understand what is ROC curve, what is area under curve, what is receiver operator curve, what happens internally, what is the use of using it, what is the actual purpose of using it. A lot of people will not mention all these things. That is what we are going to learn. That's where we are going to spend a lot of our time in this course. Apart from that machine learning, we're also going to learn how to process text data, how to build text mining algorithms using Python, using R. We're also going to use Spark libraries, which can also build some NLP techniques on top of text formatted data. And deep learning, considering that deep learning is actually part of artificial intelligence, we're also going to understand how this deep learning or neural network algorithms works, and how to use these deep learning or neural network algorithms in machine learning, and how to build some predictive models using this deep learning. That's what we're also going to learn, and we're going to implement all these things using 3 languages. Like, either we'll be seeing how to implement it, any algorithm, using Python. We'll also see how to implement it using R. We'll also see how to implement using Spark on big data technology. Just building the algorithm itself is not enough. You need to understand how to implement it. How do you deploy it? What is the steps that people will follow to deploy any algorithm into production? And what are the procedures that they will continue after deploying an algorithm into production? How to assess the model, how to assess the accuracy, when to retrain the model. Is it something that the machine learning algorithm, once you deploy it, it's not going to work for your entire lifetime? There are places you definitely have to continue to monitor it. You need to understand when to retrain it, and how to retrain it, when to retrain it. This is what we are going to learn. And also we are going to see how to attend data science interviews. What are the common mistakes that people will do when building a resume, when attending an interview? I used to get a lot of complaints from so many people that I used to work in, all that I used to discuss with, where they will say, hey, I'm not getting in any interview calls, even keep on updating my resume, because they will do a lot of mistakes. By looking at the resume itself, people will reject the CVs, because everybody is learning data science nowadays. Every person is learning data science nowadays. It will be very easy for organizations to identify who are the people who actually knows data science. And that's where a lot of people are miserably failing to build their resumes or to attend the interviews. And that's what we're going to learn as part of this course.